This lesson is the Chapter 2 review for the test. Let's start out with some questions that are always, sometimes, never. Obviously, you see the answers in the answer column. Make sure that you cover those up so that you don't see them and think that you know the answer when you truly don't. First one, so you're saying, does it always happen? Does it sometimes happen? Does it never happen? An obtuse angle has a complement. Well, think about it. What does it mean to be a complement? Complement means to add to 90. An obtuse angle is over 90. So this will never happen. An obtuse angle can never have a complement. Number 2, the bisector of two adjacent angles are perpendicular. The bisector of two adjacent angles are perpendicular. Well, if you think about it, if you have two adjacent angles, the only time that a bisector bisects to be that would look like this picture. This is one out of a million times that this happens. So this answer ends up being sometimes, because one time this can happen, where this is the bisector. And these two angles are adjacent. Number 3, if two angles are supplementary, their sides form two pairs of opposite rays. Okay? It says if two angles are supplementary, their sides form two pairs of opposite rays. So in this picture, you have sides. These two are supplementary, and these two are supplementary, saying, hey, look at us, we form opposite rays. But maybe this angle here and this angle over here are supplementary. Maybe these two angles are supplementary, but then they don't form opposite rays of each other. So somewhere it needed to say that they were adjacent in there for that to always happen. So in this case, this sometimes happens. Number 3, the supplement of the complement of an acute angle is obtuse. So what do we start with? We're starting with an acute angle. So pick a number. Okay, so the acute angle, let's say you start with, I don't know, is 30. The supplement of the complement. Well, what's the complement of this? The complement of this, the comp is 60, which then means, oh, the supplement to that is 120, which is obtuse. And so that kind of happens. Now, the largest acute angle you could have, let's say, is 89, which then the supplement ends up being 91, or sorry, then it's 1, and then it's 181 for that answer. 179. So this always happens, no matter what number you pick. Number 5, if three angles are complementary, their measures are each 30. Well, what does it mean to be complementary? Complementary by definition is two angles are complementary. So this answer is never. Unless when vertical angles are complementary. Well, can vertical angles be complementary to each other? Well, sure. If you have angles, they started like this, and then this angle could be 45, and this angle could be 45, meaning that they would add to be 90, so they are complementary. So this sometimes can happen. Very rare will that happen, but sometimes that can happen. So this section here is very challenging. You will have a couple on your test that you will have to choose always, sometimes, never. And it's kind of like true or false, where it never has to happen, so that's like false. It always has to happen, so that's true. And if there's that gray area, that's the sometimes in the middle. Question 7, let's take a look at it. What do we know? Angles 1 and 2 are supplementary. So that means angles 1 and 2 add to equal 180. Angles 3 and 4 are complementary. So that adds to equal 90. And then 2 and 4 are vertical, so that means they equal each other. They're congruent. So what do we notice? We see two variables in an expression, so this means we have to set up a system. So what do we know? The first equation is right up here. 1 and 2 add to equal 180. So we got 3x plus y. We're adding x plus y plus 30 and setting that equal to 180. There's the first equation. Second equation says 3 and 4 are complementary. Well, we don't have angle 4, but we know 4 and 2 are the same. So let's take 2x minus 3y, add x plus y plus 30, and set that equal to 90. Each simplify this. So if we simplify this side, the 3x and the x, so this is 4x. We got y and y plus 2y. And this side has 30, but we want to move it over here because that's the number we need. So we subtract that over, so we left with 150. Second one, we got 2x and x, so that's 3x. Negative 3y and y, so that's negative 2y equal to the 30 can't stay over here, has to go over here, minus it over, so then that equals 60. So this is the system we are going to solve right here. Well, let's take a look at it. Well, we could do it by elimination. The 2 and the negative 2 already cancel out, so 4x and 3x, that's 7x, and we add them. 150 plus 60 is 210 divided by 7. X ends up equaling 30. Great, that's the first part. Now we need y, so we'll plug it back into one of these. And we could say, all right, we have 30 times the 3 minus 2y equals 60. Well, this is 90 minus 2y equals 60. So negative 2y, when I minus the 90 over, equals negative 30 divided by negative 2. Y equals negative over negative becomes positive. So there's y. We had x already, so we got both those in. And then the measure of angle 4. Well, we don't have it to plug into. But what do you know? Angle 2 is equal to angle 4 by this statement up here. So let's plug it into angle 2. So we got 30 plus 15 plus another 30. So the measure of angle 4 ends up equaling 75, and we're done with question 7. Yes, you will have one question on the test that is going to be a system. Number 8, we have x and y again, so it's kind of like a system. We need to find x, y, and then a, b, c, so this angle here. Well, what do we know? We know first off that these two angles right here add to equal 180, so I could make a system once again. I could say 2x plus 40 plus 2y plus 40 equals to 180. And then I can say these two this way also add to equal 180. So x plus 2y plus 2y plus 40 equals to 180, and set up another system. Simplifying this, 2x and then 2y, and then we got 40 and 40 is 80, but the 80 needs to go this way, so that means that's 100. So one equation, I'm going to write it over here, is 2x plus 2y equals 100. And the second equation, we have x and then 4y, so then we get x plus 4y equals 2, and then we only have a 40. 40 moves this way to equals 140. What are you going to get rid of? Let's get rid of the x's because we can't do it right now, so we'll multiply this one by negative 2. So we got 2x plus 2y equals 100, and negative 2x minus 8y equals negative 280. X's cancel out. This makes negative 6y. This right here equals negative 180 divided by negative 6. Negative out of negative becomes positive, so y equals 30. Plug it back in, and let's plug it back in. So we got x plus 4 times 30 equals 140. Simplify it. This is 120. So x equals 20. We got x now. We had y. And we need ABC. Well, ABC, this angle is congruent to this angle. They're the same. They're vertical angles. So we can then plug it back into here, and we can say 2y, when y is 30, plus 40. So this is 60, 60 plus 40. That means the measure of ABC is equal to 100. Number 10, let's look at the picture. We have angle 1 right here, which is x squared minus 5x. Angle 2, which is 21 minus x. Well, what do you know about angles 1 and 2? They're opposites of each other, so they're vertical angles. So, what do we know about vertical angles? Vertical angles are congruent. So what can we do with these two expressions? We can set them equal to each other, and we can say that x squared minus 5x is equal to 21 minus x. All right, we have an x squared, so that means we have to factor. We have to bring everything over, so we're going to minus 21 and add x over to the other side. So what do we get? We have x squared minus 4x minus 21 equaling 0 before we can factor. Let's take a look at it. Leading coefficient of 1, awesome. So that means x and x go here. So we do 1 times that, so we need two numbers that multiply to negative 21, but add to negative 4. The numbers you think of. How about negative 7 and positive 3? That gives me negative 4. So this answer is 7. This answer is negative 3. Maybe they both work. Maybe they don't. We don't know. Let's try it out. So if I put in 7 here, I get 7 squared minus 5 times 7. That's a positive value. All right. We get 21 minus 7, positive value once again. All right. The next one, negative 3. Negative 3 squared. So that's 9 minus 5 times negative 3. Well, this is 9 plus 15. All right, so that's 24. And then 21 minus a negative 3 equals 24. So they both work. But we want angles TVW, this angle here, which is the supplement to both of these two angles. So if we know that this angle is 14 or 24, the leftover ends up being, when x equals 7, the other angle TVW is equal to 166. And when x equals negative 3, TVW equals 156, and we're done. Number 11, last one on the front side, we got A and B are complementary, so they add to equal 90. B and C are complementary, and then we have A and C. We don't have B, so we can't say, oh, A plus B equals 90. But what do we know? We knew a rule from 2.4 that B is the same angle, and when these are complement to the same angle, the complements of the same angle are congruent. That means these two right here are congruent. So we can say that x squared minus 25 is equal to 5x minus 1. This is what we can factor. We have an x squared, so let's minus the 5x and add the 1 over. Minus 5x, add 1. So we get x squared minus 5x minus 24 equals to 0. This is what we need to factor. Leading coefficient of 1, great. So we got x and x. We multiply here, so it multiplies to negative 24, but adds to negative 5. Think of the two numbers, negative 8 and positive 3. So this answer is 8. This answer is negative 3. Make sure they both work. Let's try negative 3. So let's do 5 times negative 3 minus 1. Well, that's a negative 15 minus 1. So that's negative 16, so negative 3 does not work. That means 8 has to work for x. Find the measure of b. Well, we don't have it, but what we can do is we can plug it back in to 5 times 8 minus 1, so that's 39. And b is the complement to that, so we'll do 90 minus 39, giving me my answer of 51 for the measure of angle B, and we're done with the front side. Page 2, we started out with a picture. We have this angle 28 minus 4x. This angle is 2x squared minus 6x plus 52. Well, what do you notice? It's making a straight line. Two angles that are adjacent form a straight line or supplementary. So we can say that 2x squared minus 6x plus 52 plus 28 minus 4x equals to 180. We need to simplify that. This side simplifies to 2x squared minus 10x plus 80 equals to 180. Before you can factor, it has to equal 0, so minus this over this way. 2x squared minus 10x minus 100 now equals 0. Now we can factor. Doesn't have a leading coefficient of 1 yet, but wait a second. Even, so that means we can pull out a 2, leaving with x squared minus 5x minus 50 equals 0. So now we need to factor this has a leading coefficient of 1. So this we could go right into x and x. So this, when you multiply two numbers that multiply to negative 50, but add a negative 5, is negative 10 and positive 5. So this answer is 10. This answer is negative 5. Got to make sure they both work. So negative 5 when I plug it in, 28 minus 4 times negative 5. So this is 20, so that's 48, so that works. And put 2 times negative 5 squared minus 6 times negative 5 plus 52. So this is 25 times 2, so this is 50. Negative times negative, that's positive, so that's 30. And then 52, so we got 132. So this does work. Let's try 10. So we get 28 minus 4 times 10. Well, that's 28 minus 40. So that's a negative value. So 10 doesn't work. The only answer is x equals negative 5 for the answer. Number 13, the ratio of the measure of angle 1, 2, and 3 are 3 to 7 to 2. So we got 3 for 1, 7 for 2, and 2 for 3. What do they all need? They need an x on them. The picture shows that 1, 2, and 3 make a straight line, so we have 3x plus 7x plus 2x, setting it equal to 180. That's 12x equals 180. So x ends up equaling 15. Got x. Now we want the measure of angle 2. So that's 7 times 15, which equals 105, which equals the measure of angle 2. Number 14, the ratio of the angles measure to its complement measures is 7 to 8. Find the larger measure. So 7x plus 8x ends up equaling our 90. That's 15x equaling 90. So x equals 6. We want the larger angle, so that's 8x. So we got 8 times 6, which equals 48 for our answer. Number 15, BA perpendicular to BG. BA perpendicular to BG. Well, if things are perpendicular, they make a right angle, and then a right angle equals 90. So this angle is 90 degrees. BD trisect CBG. CBG. So this angle and this angle and this angle are all congruent. So I consider one x, another one's x, and another one is x. And that angle is 3214. So we got to use our minutes and seconds. We want to find EBG. So we want to find one of these sections. So where do we start? We start by saying, hey, we have 90. Let's subtract 3214. Well, we got to borrow. So this becomes 8960. Subtract the 2, we get 57 degrees 46 minutes. That's for all three of these is 57:46. So what we want is we want one section, so we could take this answer and divide each piece by 3. When doing that, this becomes 19 degrees. When I do this, I get 15 and 1/3. Well, I can't leave this as 1/3. Well, I can take the 1/3 and make this into seconds. 1/3 seconds is 20, so this final answer is 19 degrees, 15 minutes, and 20 seconds. Question 16, we got angle 1 and angle 2 being congruent. Angle 3 is 50. We know that ABE, this angle right here, is 6x plus 1, and this angle right here is 10x minus 47. Well, if we notice when we look at the picture that these two overlap, so angle 3 is reflexive. So what we can do if these two are reflexive to each other, we can say, hey, angle 3 is reflexive, 1 and 2 are congruent, so these overlapping pieces are congruent, so we can say that 6x plus 1 is equal to 10x minus 47 minus the 6x over this way, add the 47 the other way, so we got 48 is equal to 4x. So x equals 12. We want the measure of angle 1. Well, what we can do is we can say ABE is equal to 6 times 12 plus 1, which is equal to 73. So this angle over here is 73, but that's 50. So 73 minus 50, I'm left with 23. So this angle is 23, which means this angle is also 23 because they're congruent. So the measure of angle 1 is equal to 23, and then we want to know, is BA perpendicular to BC? Well, if these are perpendicular, they have to equal 90, and you could take 23 plus 50 plus 23, which equals 96. So BA is not perpendicular to BC. 17, AB is congruent to CD. So AB congruent to CD. AB is x squared minus 2x. BC is 4 minus x. And BD, the whole thing, is 22. Well, what I would do is, since this is the same as this, I'd also call this x squared minus 2x. Wouldn't worry about it. These two sections here have to be 22. So I would say x squared minus 2x plus 4 minus x, that it equal to 22. I would solve it by simplifying, so I get x squared minus 3x minus 22 this way, so I get minus 18 equals 0. Does it have a leading coefficient of 1? Awesome. So x goes here and here. Two numbers that multiply to negative 18, but add to negative 3 are negative 6 and positive 3. So this answer is 6. This answer is negative 3. Got to check to see if they both work or if one of them doesn't. Well, I look at this piece right here and I say, hey, 4 minus 6, that equals negative 2. So the positive value doesn't work. This time, once again, negative 3 works. AD, you want the whole thing. Well, you know this is 22, so plug in negative 3 here and say negative 3 squared minus 2 times negative 3. Well, that's 9, and that's a positive 6, so this is 15. And 22 plus 15 equals 37, which is AD. Question 18. The sum of an angle supplement and twice its complement is 216. Here's your equal sign. The sum means add, so we got the angle supplement. Angle supplement is 180 minus x, and we're adding twice its complement, 2 of the 90 minus x's, and setting equal to 216. Simplify this side. This is 180 minus x plus 180 minus 2x equaling 216. Simplify this side. We get 360 minus 3x equals to 216 minus the 360 over negative 3x is now equal to negative 144 divided by negative 3, so negative divided by negative becomes positive, so that's 48. Find the measure of the complement of the original angle equals 48. The complement is 90 minus 48, which ends up equaling 42 degrees. 19. An angle is 30 less than 5 times the measure of its complement. An angle is. So right there, so here's your equal sign. So we'll say, we'll put this information here. So x equals 5 times the complement, which is 90 minus x, less than that, so that's minus the 30 at the end. X equals 450 minus 5x minus 30. Add this way, so that means 6x, and this side became 420. So x ends up equaling 70. All right. So then we want to find the supplement of the angle. So this is the original. That means 180 minus 70. That is equal to 110 degrees, and we're done. And last but not least on this page, number 20, we got angle 1 is 141 degrees, 47 minutes, and 28 seconds. So that's easy because that means angle 3 is 141, 47 minutes, and 28 seconds. 2 and 4 are also the same because they're vertical angles to each other. But the problem with that for vertical angles ends up equaling adding to 180. So we'll take 180 and we will subtract 141 degrees, 47 minutes, and 28 seconds. All right, over here. So when we do that, we have to borrow. So this is 179, so that makes this 60. Still need to borrow, so 59. And this makes this 60. Subtract the 2, get 32 seconds. Subtract these two, get 12. And subtract these two, get 38. So this answers the measure of angle 2 and the measure of angle 4. Continuing on, we're up to number 21. We have AB and BC are in a ratio. So AB is 3x, BC is 4x. Then we also know that BC is 6x and BC is 7x. And then we know that this AB is 18x. So find the expression involving x for CD. Well, how much bigger does this get to this? So to go from 3x to 18x, I multiply by 6. So that means this 4 has to be multiplied by 6. So that becomes 24x for BC. And if BC is 24x, how does the 24x become the 6x? Well, that means you multiply by 4, so then we multiply this piece over here by 4. So CD ends up equaling 28x, and we're done. I know it's a little confusing and challenging, but that's, you know, an upper level question that can be challenging. Next question, we want x and y. Well, what do we notice? All three x's right here make a straight line, so 2x plus 3x plus x. 2x plus 3x plus x, set it equal to 180. 3, 4, 5, 6x equaling 180. So x ends up equaling 30. You want y. Y is the vertical here to here. So 2 x's, 2 of the 30s ends up equaling y. So 60 equals y, and you are done with that question. 23. AC is congruent to EC. AC, so this side right here is congruent to EC, this side right here. BC bisects, so that means all these little pieces are congruent. So this piece congruent here, which is congruent here and here, because what do? You do like divisions. If the big pieces are congruent, all the small little pieces are congruent. So we got like divisions. But how much does y exceed x? So well, when you look at it, what can you do is you can say, okay, using like divisions, I can see all the pieces are congruent, so I can set x plus 8 equal to 3x minus 4. Solve for x. So x equals 6. When I do that and I plug it back in, this makes this piece 14, which means this piece has to be 14, and I want this piece to be 14. So 2y is equal to 14, so y equals 7. So how much does y exceed x? So if y equals 7 and x equals 6, this exceeds it by 1. If I want the perimeter, well, that piece is 14, and this is y, so we get 3 times 7 minus 1, so that's 20. Add up all of these pieces here, and the perimeter ends up equaling 76. 24. Give me the reason. VM is congruent to YV. MR congruent to YW. And we want VR. This is what we want. Well, what happens? End result bigger, so this is addition. Next one, we got BD bisects AE and AC. So BD is bisecting, causing these two to be congruent and these two to be congruent. But then DE is congruent to BC. So then this is smaller. So we want AE, this is bigger. So this answer is like multiples. Remember, two bisecting pieces. Either use like multiples or like divisions. 26. AB is perpendicular to BC. Well, if perpendicular, this is definition of perpendicular, causes a right angle. Right angle and right angle, so 27 is all right angles congruent because they're both right. That gives you this. This statement was given, so what are we doing? ABC here, and this angle are congruent, and then we got 3 is congruent to 6, and we want 4 and 5, so we're getting smaller, and this answer would be subtraction for 28, because we are minusing to get smaller. Rolling on to the last page, we got two bisecting pieces, so it's either like multiples or like divisions. We got ABC, this big angle here, and DEF, this big angle here. They're being bisected. We want 1 and 4. So 1 and 4 are obviously smaller. So this has to be like divisions because you're getting smaller. Vertical angles, that gives it away. So it's vertical angles are congruent, and then 1 is congruent to 4, 4 is congruent to 1. This is that idea of the transitive property where you don't have to do the substitution by converting it. These are adjacent and form a straight. So if two adjacent angles form straight angle, then supplementary. This is given 2, so then this one would be definition of supplement. Well, 3 and 4 are supplement, 3 and 2 are supplement. 3 is the same angle, so this is the supplements of same angle are congruent. Okay, this one right here would be vertical angles are congruent, and then of 1, 2, 4 and 2, 2 and 1, so we just transfer them around, so this is transitive property once again. And last but not least, the two proofs that you have to do on your own. QB bisects AQC. AQC. So these two end up being congruent. It's going to give you angles 1 and angle 2 is congruent. What else do you know? You know that 2 and 3 are congruent because of vertical angles. You know that 1 and 4 are vertical because vertical angles. So that means 3 and 4 also have to be congruent because they are all going to be congruent. So what does that look like? Well, you start with QB bisects angle AQC, which gives you, with reason 1, angle 1 congruent to angle 2. From the diagram, second reason, you know that angles 2 is congruent to angle 3. And then you also know from the diagram, same reason, angle 1 is congruent to angle 4. Well, 1 is 2, 2 is 3, 1 is 4, so bracket all these together. Up the reason 3, you can say angle 3 is congruent to angle 4 because any of them that you want are congruent. First one is a definition of angle bisector. Reason 2 is the vertical angles are congruent. And 3, we're at that transitive property. There will be one just like this on the test on your own. Last but not least, 1 and 2 are complementary, so these two add to equal 90. 3 and 4 are complementary. We want to prove that 1 and 4 are congruent. Well, what else do we know? That 2 and 3 are vertical, so let's use that comp rule. Hey, this is great. So the measure of angle 3 plus the measure of angle 4 equals 90, given. We can get arrow out and say that angle 3 and angle 4 are complementary. We also know that angle 1 and angle 2 are complementary because that's given. We need a vertical. Oh, from the diagram, second reason, angle 2 is congruent to angle 3. All three of these together, third reason, angle 1 is congruent to angle 4. There will be one just like this on your own too. Reason 1 is definition of complementary. Reason 2 is the vertical angles are congruent. And 3 is the complement of congruent angles are congruent. There is your review sheet. I know it was kind of long. Um, Hopefully you were able to perform well at it and you will be able to perform well on the test. Good luck to you and keep continuing to study because I know you will do well if you do.